Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help you understand a process called completing the square, and I put a little smiley face here because this is always students' favorite method for solving quadratics. So to understand completing the square, it's necessary that you know FOIL method really well. So look at what happens when you take anything like a plus b and square it, right? So that's equal to a plus b times a plus b, which when you do the first term you get a squared, and then you have plus ab plus another ab, so you end up with 2ab in the middle plus b squared. And the idea behind completing the square is to try to take something like this and write it like this. So we're kind of undoing the multiplication, so to speak. Now you'll notice that this b squared term and twice b. The idea behind completing the square is focusing on the 2b, figuring out what that needs to be, and making sure that this value is equal to the b squared. So you kind of look here and you decide what b is. Then you make sure there's a b squared here. And once you have it in this form, then you know the thing will unfactor, if you will, into a plus b, the quantity squared. The trick is this guy, how to make this look like it needs to be so that we can do this process. So I think the easiest way to do it, to get this across, is just demonstrate what that kind of looks like. So when we're completing the square, it's a different type of process than factoring or using the quadratic formula. What you usually do here is you just look at the squared term and the linear term, and don't worry about the constant for now. And what you do here is I'm going to rewrite this. I'm going to leave myself a little space here, and you'll see why here in a moment. And the idea is that I got to figure out what number needs to be here to make this a perfect square. Now, if it's going to be a perfect square, that means that the factorization is going to look like this, because that lead term needs to be an x squared. And you notice that this is an 8x. In order to give me an 8x, these terms must be 4 and 4. So that 4x plus another 4x, there's my 8x. But if these are 4s, the last product would be 16. So I need a 16 in this spot so that this thing on the left-hand side is equal to this, which is a perfect square. Now right now there's not a 16 there, but it's an easy fix. I will just add 16 to the left. Now, if you add something to the left and you have an equals here, you have to add it to the right to maintain equality, both sides. So by adding that 16, this left side now is now equal to x plus 4, the quantity squared. So I'll go ahead and write it like that. X plus 4 squared equals. Right-hand side, let's see, is 16 plus 7 is 24. 23. Right. Now we can solve this by square rooting both sides. So if we square root both sides, now we're going to have x plus 4 equals plus or minus square root 23. And again, look to my previous video on square rooting both sides. Remember, there's two possibilities here. When you look at this equation carefully, it says x plus 4 squared equals 23. Well, the x plus 4 could be a positive value squared and gives you 23, but it also could be a negative number squared and still get plus 23. So, moving on. Next step is to just subtract 4 from both sides. And this is done. There's really not much more we can do with that. 23 is not a perfect square. And, you know, we could get a decimal approximation for this, but we'll just leave it alone. And we have two answers. One answer is negative 4 plus root 23. The other answer is negative 4 minus root 23, and that thing is done. All right, I'm going to probably need a little more room. All right, let's take a look at this one. So this guy, let's start by getting these together. 3x squared minus 7x, and I'm going to leave a little space, equals negative 2. That's what we get by subtracting 7x from both sides. The reason for doing that is when you're trying to complete the square, you're focusing on this stuff. Now, completing the square isn't much fun when this value here is not a 1. The first thing I recommend here is just try to make that thing a 1. We can do that by dividing the 3 out. Now we have fractions, but that's all right. The next step is to realize, all right, this is going to equal x minus something times x minus something. We're trying to make this equal to some sort of perfect square. Whatever these somethings are, they have to give us this value. So the somethings, just like in the previous problem, you notice that this was 8, and we ended up needing 4s here. The value that goes here and here is always going to be half of this middle number. Half of 7/3 is 7/6. Now, you'll notice that if we multiply these out, when you do the outer and inner term, we get minus 7/6, minus 7/6. That ends up being minus 7/3. We're fine there. The last product here is going to be plus 49/36. Now, we don't have a plus 49/36 here, but we can fix that. Plus 49/36, as long as you do both sides. This left-hand side, by design now, is equal to this. Right? Multiply it out and you'll see. Boom. Outer and inner gives this. Last term gives this. So this left-hand side is now equal to x minus 7/6 squared equals right-hand side. Well, let's see. I guess we're probably going to have to combine these, which is fine. If I want to write this with a denominator of 36, I'd have to multiply it by 12. So times 12 times 12. So this is now negative 24/36 plus 49/36. Let's see, 49 minus 20 is 29, minus 4 more, 25/36. All right, so x minus 7/6, the quantity squared, is equal to 25/36. And now, the fruits of our labor here. Why did we do all this? Now we can proceed to solve for x by square rooting both sides. So x minus 7/6 is equal to, now again, keep in mind, when you square root both sides, the principal square root would be 5/6, but minus 5/6 also solves this equation. Right, so we're going to have two values here, one plus and one minus. This is always going to happen when you take an equation and you square root both sides like this. Right, so one possibility is that x minus 7/6 is equal to minus 5/6. Other possibility is that x minus 7/6 is equal to plus 5/6. Solving this one for x by adding 7/6 to both sides, that's going to give us 2/6. When you take minus 5 plus 7/6, which is 1/3. There's one solution. Over on the right, when we add 7/6 to both sides, we're going to get 12/6, which is 2. So our two solutions are 1/3 and 2 for this animal. Now at this point you might be saying completing the square seems like a lot of work, and sometimes it is. I would tend to agree with that. It can be. Take a look at this other animal here. All right, so number 26 here. Under completing the square on page 276. So 4z squared minus 8z minus 5 equals 0. Well, the first thing we're going to do is take care of this. Completing the square, not much fun when that's not a 1. It's pretty easy to make a 1, just divide everything by 4. So our next line is going to be z squared minus 2z minus 5/4 equals 0. Now, when you complete the square, you're usually focused on this. This is what you have to deal with. This might as well go over to the right. So if we add that to both sides, we'd have positive 5/4 on the right. Next step. What I do when I complete the squares, I start thinking, what does this need to look like? All right, we want to design this so that it's equal to z minus something and z minus something. And when I say design, that's what we're trying to do. We're trying to figure out what do we add here so that this can be written like this. And the minuses are because this thing's minus. And you look here, and you take that value and you cut it in half. 1 and 1. And the reason you cut it in half is because the outer and inner terms need to give you this middle term. And notice that it does. Minus z is minus 2z. But the last term would be plus 1. So we need to add a plus 1 here. These are now exactly equal. Now you can't add 1 here if you don't add it to the right-hand side. So plus 1. Same thing with this line, plus 1. So this is the completing the square part. I now have turned this into a perfect square by adding 1 to both sides. So this is now equal to z minus 1 squared equals. Right-hand side, how about we do this? 5 over 4 plus 4 over 4 is 9 over 4. Then you square root both sides. Z minus 1 equals. Now the principal square root is 3/2. So the z minus 1 could be 3/2. But it could also be minus 3/2. So it could be plus or minus 3/2. Because what you have to do is you have to realize right here, if I put minus 3/2 there and square it, I get positive 9/4. So that's why we have two solutions there. So now we get two different tracks to the answer, if you will. One possibility is z minus 1 could equal 3/2. Other possibility is that z minus 1 equals minus 3/2. And then you just solve them both individually. So in this case, z is going to equal 1 plus 3/2. Let's see, which is 2/2 plus 3/2, 5/2. Other possibility is z is equal to 1 minus 3/2, which is 2/2 minus 3/2, which is minus 1/2. And there's our two solutions to this. And again, remember, quadratics, when you have second power, you either end up with two solutions, or sometimes one solution, or no solutions. Those are the three possibilities, and in each one of these cases we ended up with two solutions. So again, the video here was to help you hopefully realize how to complete the square. I hope that that's effectively done that for you. Have a great day.